Why do flat Earth models have 8 billion domes over each observer? That's a good question because it shows that the person asking either wants to learn or is trying to do like a one up gotcha question, and then it reveals that they don't know what the equatorial grid is. And it also reveals that they don't even know the globe models. Any globe astronomical app will show this exact same dome that I have. We just zoom out so you can see the whole world. But it can be confusing. So over here on the right side of the screen, I'm using Stellarium and I placed us in Toronto, and that's where the top left observer is on the flat Earth model. So you can kind of already see from the right hand side there's a little dome above us here, even on the globe app, because we see in a spherical field of vision. That's just how it works. Now, in Stellarium, you can't zoom out because the globe, they're only limited to one observer. Because if you take, for example, the flat Earth model on the left hand side and try to wrap it around a ball, you can't zoom out to show people how the world really works because the world flat with a dome over us and everything's going around. So that's why on the flat Earth model, when someone's first presented to it and they see the bird's eye view, something that the globe just cannot do, it really impresses them, and they're wondering, okay, what is this? How does it work? And I can show you. It's not really that complicated. So you see how the sun here is going to be to the right of the observer. So I can go into the like exact same thing the globe does because that is your perspective field. This is how you see. And then if I look to the right, will the sun be there? Where is my sun? Okay, yeah, my sun's right there. That's my perspective. And then on the globe app, if I look to the right, you're going to see it. That's just how perspective works. Now, what an astronomical model such as the flat Earth can do is we can then zoom out and you can now see, okay, where is this light actually coming from? How does the sun shine through the dome firmament, and how does the dome refraction end up putting a light to each observer? Now, to be clear, the globe model doesn't even attempt this. They don't even have an argument. All they do is just first person views like this. So you see now how we're in Ukraine, and then according to the flat Earth model, if I look to the left, we'll see the sun should be just rising. And that is correct. You see that the globe can replicate the flat Earth model pretty well. So they know that the sun is there, but they can't actually tell you that, okay, it's this high on the dome firmament. So let's see, we know that right now the sun is actually 4,031 miles above us in altitude on the firmament. And that's because this is a quantified astronomical model. And then finally, if we go to Argentina, let's also open that up in our stellarium. Facing north and looking up, yeah, the sun's right there just like it shows, except now we notice that the wrapping of stars, that celestial pole, is facing to the south. Why? Well, simply put, you're now on the opposite side of Earth's torus field. So you see right here how in the flat Earth model we can turn on the toroidal field that's coming out of Mount Meru, and we can actually see how it looks. And then it becomes very clear, okay, why do we have an equator? Well, because it's the middle of the magnetic field. So then it makes sense how star trails work, how perspective works, how all these little domes work. That's why. I don't want to go into that too much. That's another video. I just want to explain why any astronomical model, including the globe, does have 8 billion little domes over them, and that's perfectly fine. It's called the equatorial grid. So when you go into Stellarium, use that bottom menu down here. Stellarium's a free app, which is a very good introduction to how the world works. It's extremely basic, but if you don't even know about the equatorial grid, check it out, see how it works. It's very, very cool, and you can compare it to the flat Earth model and see how they're similar, what the limitations are of the globe model and the superiority of the flat earth model. Because what we can do is we can actually now like see, okay, where is everything on the firmament and how is it now being projected down through due to the refraction as light shines on a dome. It's quite fascinating and it's accurate. We just did 3 observers to show that it is 100% accurate. It was Toronto, Ukraine, and Argentina. Matches exactly what the flat earth model predicts, except we can zoom out to see. But again, if zooming out confuses you, if you're a glober and you're new to like science and this is the first time being introduced, you can use the button up here to go into the first person view and you can see how the astronomy apps that you may be used to kind of work the same. So start with this and then work your way out to seeing how the world actually works and then seeing all the little perspective domes. So I hope that clarified everything. Have a great day, guys.